Okay. Hello everyone. Welcome to the first lecture on matrix spaces. So today I'll introduce the concept of what is meant by a matrix space. So many people don't understand what is a matrix space. So I'll talk everything from the beginning and let's see what exactly is a matrix space. So let's talk about matrix space. So before talking, like giving a basic definition and everything, let's see what we know about distance. Okay, so distance. Okay, just a minute. Maybe yeah. So we all have the concept of distance. Okay, like हम लोगों ने बचपन से रियल नंबर लाइन के बारे में पढ़ा है. So this is your real number line R. 0, this is 1, this is 2, this is 3, this is -1, this is -2, this is -3, and here is 1.5, and this is the real number line. So if I ask you what is the distance between 1 and 3, okay, if I ask you what is the distance between 1 and 3, so you can clearly answer me that 2, because you can see from here 1 and then 2, right? So the distance is 2. So distance between, I'll write this here, okay, 1 and 3 is 2. Similarly, if I ask you distance between -2 and 1, what is the distance? So again, you know this. So this point, take this point and take this point. So how many gaps are there? 3. You know this answer. But just hold on for a minute and think, how are you determining this distance? What you are doing, you are subtracting the bigger number, sorry, you are subtracting the smaller number with the bigger number. You see this, what you are doing here, this is nothing but 3 minus 1. And what you are doing here, you are taking the bigger number among these two, between these two, which is bigger 1. So 1 minus minus 2, and this is nothing but 3. So this is how you find distance between 2 points in real line, real numbers. This you have been taught in your lower studies. Similarly, you can find the distance between 1.5 and 2.7, and this distance is nothing but 2.7 minus 1.5, and this is nothing but this is how much, 1.2, right? So this is the distance. This fact you know about distance. Now let's see what are the other facts you know about distance function. So instead of writing d now, this distance, I'll be writing just d. Okay, so let's see what are the facts about d. Let me write it down, distance d. Let's see what are the facts we all know regarding this distance function d. This, okay. So this is the fact number 1. You take any two real numbers which are same. Like for example, what is the distance between 1 and 1? Is nothing but 0. What is the distance between 5.5 and 5.5? It is again 0. So that is our very obvious thing, that is very intuitive, that whenever both the points lie on the same place, okay, what we can say that the distance between them should be 0. So for example, if a point x is here and y is also here, then distance between x and y should be 0. That is very intuitive. So what fact I know about this distance function, the distance between x and y should be 0. Okay, not like this, so sorry about it. Distance between x and x should be 0 for all real numbers. I'm only talking about real numbers now. Okay, and not only that, one more fact that we know, if I tell you distance between 2 points is 0, then that is again very intuitive that both the points must be same, right? So that should also implies the distance between, sorry, that should implies that x should be equal to y. So this is two fact, or precisely one, I will say, like merging these two together. So this fact we all know about the real numbers, that if the 2 points are same, then their distance should be 0, and if the distance between 2 points is 0, then the points must be same. And this should be true for any distance. Suppose I and my friend are standing at the same place, okay, then you think what should be the intuition, that distance is 0, that means sorry, so what I am saying, that suppose I and my friend are standing at a place at the same place, then that is very obvious that the distance between us should be 0. Okay, and secondly, if I say that distance between me and my friend is 0, then that should implies what, that I and my friend are standing at the same place. Now what another fact do you know? You know, a very nice fact about real numbers is this: distance between 1 and 2 is same as distance between 2 and 1. This is very easy. What is distance between 1 and 2? It is 1. And what is distance between 2 and 1? It is again 1. So this should be true for all real numbers. That means, so what is this? This says that distance between x and y should be same as distance between y and x, and this should be true for all real numbers x and y, that I'll write later on. So this is again very intuitive thing, that a distance function should follow. That means distance between Siliguri and Kolkata will be same as distance between Kolkata and Siliguri. This is a very trivial fact that any distance function should follow, right? And the last fact, which is again very important and not that intuitive, and mostly you have done this in lower studies, you see this fact. So suppose, okay, just a minute, yeah, suppose this is a point and this is another point, right? So this is the distance between them, that's all, right? This is the distance between x and y, the straight line joining x and y. Suppose if I choose, so I want to go from x to y, so if I go directly, this is the path, or if I take any other point, go there first and then go to y, so this is distance between x and z, and this is distance between y and z. If I go from x to y directly, or if I go via z, which is going to be the longest path? Definitely this one. This is your intuition, and sorry, this again comes from what you have learned in your lower studies, that the sum of any two sides of a triangle is greater than the third side. Okay, so this should also be true. That means if you want to find the distance between x and y, then that is the smallest one, smallest in the sense, if you choose any other point, like anywhere, okay, the distance between x to y will be less or equals to distance between x and z, and then z and y. So that is another one fact that you should know. Distance between x and y should be less or equals to distance between x and any other point z, and then go from z to y. Like for example, look at the distance between 1 and 3. The distance is 2. I'm talking about real numbers. Now if I take a point 2 in between, so what is distance between 1 and 2, and distance between 2 and 3? This is how much? 1, and this is how much? Okay, in this case it is coming equal. It may be equal. I have written here equality also. Like, why this is happening? Because if I take the point y here, z here, then definitely this distance and going to z first and then going to y will be same. So these are the facts that we know about any distance function or about the distance function over the set of real numbers. So mostly these are the two facts. Okay, this is the third fact and this is the fourth one. And what we want, or what should be true, that this four conditions must be true. These four conditions must be true for any distance function. Like what I mean by any distance function, like for example, so consider this set. Okay, just a minute. Yeah, uh, consider this set. So let x equals to, x has suppose 3 points a, b and c. I don't know what are the points a, b and c. They can be anything. Okay, so these are just some arbitrary variables, you may think, a, b, c, which are the members of the set x. So I want to introduce the concept of distance between these points a, b, c inside this set. This set has only three members. So while introducing the concept of distance, I have to keep these four facts in my mind. That means, suppose here d denotes the, suppose d represents the distance function. Then what I want, distance between a and a, distance between b and b, and distance between c and c. I want all of them to be 0. That is very obvious. And what I want, distance between a and b should be same as distance between b and a. Distance between a and c should be same as distance between c and a. And distance between what is remaining, b and c, should be same as this. I want. I don't want this to be different. I want this to be same, this to be same, this to be same, right? And I also want that something like this, distance between a and a, sorry, distance between a and b should be less or equal to distance between a and c plus distance between uh, c and b. One more thing I should tell you, which I forgot to mention, and which is very important fact, that the distance cannot be negative. The distance cannot be negative. So this is another fact which I should have mentioned here. So this should be the first fact actually I'll mention here. So the first fact should be this: distance between x and y cannot be negative number. That makes no sense. Like when you talk about distance should be a non-negative quantity, and this you can verify for the set of real numbers also, right? So what another thing I should state, distance between a and b should be greater or equal, should be greater than 0. Distance between b and c should be greater than 0, and distance between, and should be a real number. Okay, they must be a real number. So a and c should be more than 0. This also I should want. So I am introducing the concept of distance in any arbitrary set x, right? But even if I am defining the concept of distance in any arbitrary set, I must keep these things in my mind. Okay? This should be a very trivial thing for any distance function to satisfy. Right? So I'll write these 4 points in a very nice manner, maybe a bit later. So last thing that I should tell you, so let's talk about the distance function. Now we are ready. Distance function, to define what is the distance function. So in mathematics, distance function is called as a metric. It is not called distance function anymore. It will be called as a metric. Okay, so look at all of the things which I wrote here. You see, I am always inputting two things inside D, because distance, like distance between a distance for a single point makes no sense. So if I'm talking about distance, I should talk about 2 points at least. Okay, so what does a distance function does? It takes two things as an input. Can you see? It is always taking two things as an input. It is taking here two things as an input, and it is producing real numbers, right? It will always produce real number. The set x may not have real numbers, but the distance, the length between 2 points should be always a real number that we want. So a function D, so D is a metric. So what it takes two elements. So just a minute. Yeah, it takes, so I should write, okay, just a minute. So I need a set first of all. So let x be any non-empty set. Suppose this x is any non-empty set where I want to introduce the concept of distance, right? Now, just a minute. Yeah. So define D. What will D do? It will take two members of x and assign a real number. This is what we want. What will D do? It will take two real numbers and assign them a real number. It will take it will take two members of x and assign them a real number, what is called as the distance between that 2 points. So define this by such that, or satisfying. So any function like this may not be a matrix. So define this satisfying. So it has to satisfy so many points. So the first point should be distance between the two members x and y of x should always be non-negative for all x comma y in x. This should be the first thing. Okay, this is known as the non-negativity condition. The second fact that I want to be true, distance between x and y is 0 if and only if x equals to y. Again, this is true for all x comma y in x. So that means if 2 points x and y, if 2 points x and y are same, then their distance should be 0, and if their distance is 0, then both the points are same. So that should be true. And third point, the symmetricity, that x comma y should be same as distance between y comma x. So this is what is called as the symmetry. So symmetric. And the fourth one is the triangle inequality, which already mentioned, distance between x and y should be less or equals to distance between x and z plus distance between z and y. For all, here also I should write for all x comma y in x, for all x comma y comma z in x. So that means already explained, and this one is called as the triangle inequality. So any function, so let me write it here. Yeah. So I have any non-empty set. In that non-empty set, I want to define the concept of distance. So I am defining the distance function by this, satisfying this four properties. So if any function from x cross x to r satisfies this condition, is called a metric on the set x. Okay, so this is very interesting thing here. It is called a matrix. Keep that in mind. It is called as a matrix. So this matrix or the distance function d defines the concept of distance on any arbitrary set x. Okay, the set x, the set, or I should write like this, the pair x comma d. That means I have some non-empty set and the distance function or metric on x, where I can talk about the distance between any two members of x. A pair this is called a metric space. That means I have some non-empty set and there I can measure the distance between any two members of x using this function d. So sometimes if I write x, so note or a remark, if I write x is a matrix space, so what it means that there is some distance function on x, okay, which measures the distance between any two points on x. So I am not specifying that metric function. You can take anything, like maybe you can take d or some d1 or any other thing. So if I am writing just x is a matrix space, that means there is some function which measures the distance between 2 points of x. I hope this definition of metric space is clear, and I hope you will never forget this definition, right? And yeah, so I hope you understand why it is called as the non-negativity, why it is called as symmetric property, and why it is called as the triangle inequality, because it is something like this, no? If I have x, if I have some y, and if I take some point z here, then I want this distance to be less or equals to this distance plus this distance, and this is why it is called as the triangle inequality, because you already know this fact is true for triangles, right? So let me pose few questions. So I'll give examples in the next class possibly, but let's see some things. So I hope it's clear, the definition and all, and I want to introduce, yeah, so the concept of metric space. So examples I'll talk about, but one last thing that I should mention is this. So there might be a very natural question. So given any set, given any non-empty set x, is it always possible, to define a metric on x? So that is a first natural question that should come to your mind. Like suppose if I give you the set x to be 5 7 a b. Suppose my set is this very weird set anyways. So is it always possible to define a metric on x? I've written a metric. There can be many metric, we'll see. Or now the first question is it always possible to define a metric on x? Like, can it be made into a matrix space? That means, can I make a structure on x or a function on x that measures distance between 5 and a, 7 and b, and so on and so forth, right? So this is the first question. Can I make any set into a matrix space? If yes, how? If no, why not? Right? And we'll see more concept, more examples in the next class. I hope you like the video, you understood everything. Okay, so if you like it, if you need any help, any kind of videos, you can write in the comment box to upload. Thank you.